Hey everyone, welcome to this stream. In the last stream, we were trying to create a model which recognizes different hand gestures. So not just any hand gestures, we want to recognize specific hand gestures like this one. So all of this maps out to this one to 1, 2, 3, 4, 5, 6, and this is a special one. So basically the ultimate goal is to build this game, hand cricket, using the model that we are trying to build. And for now we are just trying to create a model which recognizes these different hand gestures. And last time we tried to create a simple model and use the default arguments for the FastAI library. So today we are going to optimize this model, because as you can clearly see from the confusion matrix, we were not getting good results. So ideally we should get a diagonal line. Let me show you which kind. So ideally we should get this kind of diagonal line in the confusion matrix, which shows us that most of the classes are predicted correctly by the model. But in this case, most of the classes are false in this range. So most of the classes are classified as 2, majority of the classes. So that's where our model is incorrect, and today we are going to optimize it. So last time, let me see, I tried to use randomize resize crop. First I used randomize resize crop and it was giving me some results, and after I used this simple resize transformation, which gave us this results. So it actually made the model worse. And today we are going to try precising step. So let me show you what it is. Where is it? Precising. So we are going to try this transformation today. So let me get the path. This path basically contains all the images. Let me quickly check I have the data set or not, because it takes some time to fetch the data from Google Drive. So I have the data set. This is the data set we are using, fingers, and we are only going to use that images from this train data set, train folder, because it contains almost 20,000 images, which are enough for training the model. If we were to use more than that, or even if we use 20,000, then it will crash the Google Colab. It seems it's going to take some time. Right, let it run. Let me just copy this code. And let me edit the code so that we can use the precising step. So this is the precising step. Basically, first we resize it, and then after we apply the augmentation transforms. So if the image was this much big, we first crop this much part, then out of that cropped part we again crop random part and apply the augmentation transform like this. So augmentation transform is basically this warping from one side or stretching from one side or increasing or decreasing the lightness and all those different parameters. And finally we have this kind of image. So that's the transformation step basically. So copy the code. You already have an item transform. So first we have to resize it to a certain value for it to crop. But most of the images in our data sets are 128 by 1. Google Drive timeout has occurred. Did it occur? Oops. I might have to reload it. Let me check. I hope it runs this time, or I will have to reload the whole notebook and it takes few minutes. Alright, thankfully it did run the code. So as you can see, we have 20,000 images inside the training folder. We have selected the training folder as the path, and in the data block we are going to apply the new transformation step. So I'm confused, should we use, because most of the images are 128 by 128. I'm confused what kind of transformation should we apply in case of precising these images. We need our same dimensions so that we also want to minimize the number of distinct augmentation computation we perform. If performed after resizing down to the augmentation, various common data augmentation transform introduce spurious empty zones, degrade data road. For instance, rotating an image by 45 degrees fills corner regions of the new bounds with empty bins, which will not teach the model anything. Many rotation. Resize images to relatively large dimension, that is dimension significantly larger than the target training dimension. Alright, and compose all of the common augmentation operation including a resize to the finest target size into one and perform the combined operation in the CPU. Okay. Okay, so what if I keep resizing step to 128 only? Let's try that. I'm keeping the resizing as 128 because most of the images are by default 28 by 128 by 128 size, and after that we are going to apply batch transforms. So let me copy this line of code. Augmentation transforms, and we have to, let's see, we can use, I guess 64 will be adequate, or maybe something like 100. let's try the steps. This will give us the data block. Now let's get the data loaders from path. And if we check the data sets, it gives us back 1000 images for the training set and 200 images for the validation set. It is so because we are using a random subset splitter and we are passing the training size and the test validation size percentage, and we are not using the whole 20,000 images, all of the 20,000 images for our model. We are using just a subset using this function random subset splitter. Right, after we have got the data loaders, let's check the batch as well. This will show us the images in the batch. This was the results we are getting in the previous model. So let's see if we can beat this results. These are the images that we have got after applying the transformation, I guess. Now let's train the model. So we were getting 71, 80, 34, this kind of error rate. Let's see what error rate we get now. is taking a lot longer than the previous model we were training. Alright, the first epoch has been done. .78, 179. So it seems our model hasn't improved that much. Let's check the confusion matrix. Well, it's almost similar. We are still getting the vertical lines. And let's check top losses. So this is 4, but it's being classified as 2. This is 4, it is being classified as 2. So again, most of the images are being classified as 2. I don't know why this is happening. Is our model biasing towards 2? Where does the problem lie? Let's check most confused classes. Alright, so again 2 is on the in top. Most of this classes are being classified as 2, right? And some are classified as 6 as well. So most of the class images are being confused with 2 and 6. So almost all of the images are being confused with 2 and 6. Only one, even this one is classified. Even this one image which was not classified as 2 or 6, it's still classified as an incorrect class, it should be 5, but it's been classified as 1. So the model is definitely not operating perfectly or adequately. That should be the case. So I am not sure if these images are the ones which we get after applying the transformation. Let me check. Okay, so what if I do train.sobash? Alright, so these are the images that we get after applying the transformation. Let's check some more images. How can I get more images? So the 6 is definitely not working properly. The thumb 6 is basically like this, a thumb extended, and we can see out of these two images, both of them have thumb cut off. So there's no the most important feature of the image which can be used to predict it has been cut off. So this shouldn't really happen. So from this data set we are getting the thumb images. I want to check what kind of dimensions the images from this data set contains. So it's definitely not a square. So if we randomly crop the image, it will definitely cut off. So let's check the precising step again. Where was it? Resizing. Minimum scale 0.75. So let's check some more images. So this kind of images, where's the 2 though? So the precising step also doesn't give us adequate results, and maybe I have to change this. Let's check the validation set. These are the images from the validation set. We have 1, 2, 4. Most of the images are being classified as 2, either 2 or 6. 6, okay, 6 is this. So I guess, yeah, that's I can see why most of the images are classified as 6, because the 6 dataset is from this, the 6 images basically are thumb extended from a different data set, so it contains wide images, and if we crop them we are getting this kind of images which cuts off the thumb most of the time. So it just gives a fist, and you can see that this fist is inside other images as well. Is it that this, is it because this image, this fished image contains a very dark background, and this images have different kind of background? Maybe, is that the case? I don't think so. That would that doesn't explain yet that why we are getting this straight line for the twos. We are getting this straight line consistently for all the transformation steps. So I must be doing something wrong, or not wrong. I must be applying the transformations incorrectly, I guess. Might have to fix something. What if I scale it down to 0.3 or something? Let's get it. Now let's first get the batch. It would be helpful if I can see more than 9 images at a time. Wait, I can pass max n is equal to this parameter, right? Let's use this parameter. And we can pass, give me 15 images, and let's say keep 3 rows. Didn't even notice this argument before, max number. Alright, so we are getting a bird's view of this image. So as we can see, most of the six image does contain a thumb extended, but this one, and this one, the thumbs have been cut off, so it's not proper. And other images, well, they look all right, but these images don't look that much good. What if I try to apply the transformation to this images first? And no, but I can't do it right now because all of these images are inside one folder only. I might have to download the images again and apply different transformations. So I want to do something which will get all of the images, including the fist with thumb extended, correctly most of the times. Let's try to train the model again with we just tweak this parameter minimum scale to 0.3. So now let's try to run the model. Maybe I should also try to increase the epochs. Maybe that will affect the results. Okay, let it run for 2 epochs right now. So that we'll try to pick it again and increase the epochs. So there are many different techniques again to optimize the model. Like we can tweak the base learning rate and so on, but we will keep it for later. So those are the last optimization that we'll be doing. First I want to get some adequate results, like not a correct diagonal line, but at least some sort of diagonal line. It shows us that our model is somewhat working correctly, like not 100%, like at least 70% or something. Then we can tweak those different things later. So after this is done training, I'm going to choose 4 as the epochs and compare the results. And after that, maybe I will switch back to randomize resize crop, because it was giving us better results than anything else that we tried up till now. So maybe that's the transformation we should be using. We'll see. And I can also apply the default augmentation transform. So nothing really changed. So let's try to fine tune it for, well, let's use 5. So our model is definitely not improving. In the very least, it is getting worse during each epoch. So the training loss has been going down, but the validation loss started increasing right from the beginning. It started from 2.42, went up to 0.7.04. So that means we are overfitting our model. Error rate started from 0.69 and went up to 0.90. Let's quickly check the, so that means that increasing the epochs, and after increasing this this is very surprising. So after increasing the epochs, almost all of the images are classified as sixes. So our model is biasing toward this sixes. That's definitely not good. So I see why it is behaving like that. So it's definitely because these images are different from this data set, and this data set is all of the images are 128 by 128, while these images are not 128 by 128. And after applying the transformation, so is that something we can do? Like can we customize the transformation, like apply it to only certain kind of labels? Can we do that using FastAI library? We'll have to check it. Let's check the data block API. Data block FastAI. This might give us some hints what we should do, what we should be doing. Category block multi. Shuffle function, get IDs, get indexes, drop last index, pin memory. So I'm gonna try something. I'm just going to ignore the data set which contains sixes, this thumb extended images, which was merged from different dataset, and I'm going to use this test dataset which contains only the images which are from the same dataset, and which this doesn't contain the thumb extended images. So if our model works on this dataset, that means the thumb images are the ones which are creating tolerable. So we get images from this path. So let me copy this cell, get it. Up to, let's say, well, I'm gonna keep it as it is. So if we check, it gives us 3600 images, which are more than enough. And I'm going to try, let's see, I'm going to try randomize resize crop only. So let's get the data block. First of all, let me check how many images we are getting inside training and validations. We are getting 1000 images inside traination and 200 for validation. We're just selecting 0.005. Alright, so let's click the data loaders now, and let's try to train the model now. First, let's check the batch. Right, this are the kind of images that we get after applying the transformation and everything else. So now let's try to train the model. This might give some interesting results which will show us what is causing the trouble. Awesome. So this time our model improved. Let's check the confusion matrix. So we are getting somewhat uh, diagonal line, and I'm sure if we tweak this model some more, we can get a almost perfect diagonal line. So I'm definitely sure now that the thumb extended images are what causing the problem. So we can try something. Maybe I should, try to resize all of the images to a bigger size. If I do that, most of the images will be like this. So I'm gonna revert back to the training data set again, because we need the thumb images as well. And this time I'm going to try, let's see, we're going to try the random resize crop. Maybe we should try this transformation only. And I'm going to use a somewhat bigger random resize crop. Let's see what happens if I try 224 or something. That might, okay, it doesn't give us any errors. Let me check the source code of randomized resize crop. Well, I don't understand any of the code, so let's go on and get the data loaders. And now let's try to train the model again. Let me first check the batch. In this time we are not getting incorrect 6, so that's good. So let's try to train the model now. I'm definitely sure there is the transformation step that we should take care of, because that is what is causing most of the trouble and making our model bias towards sixes. So this first epoch is always the slowest because it trains the randomly added weights, and this epochs are training the whole model, including the pre-trained layers. So this time we are getting 0.37. Let's see if it gets worse. So it did got worse on the second epoch. I'm getting 0.52. So that's not good. It is definitely overfitting. And I'm sure this time also we will get a straight line in the confusion matrix. Oh wait, it started decreasing again, so it got up to 0.48 after the third epoch, and it started to overshoot again. So our model is behaving somewhat randomly. So as I said, we are still getting a vertical line, but this time we are getting a somewhat diagonal line. So we are getting these patches this time, but still our model is not that good. So it seems that tweaking the transformations can affect the model. So we are going to try some more tweaking to the transformations. So let's see which transform we use the randomized resize curve, right? And we basically increased it to 224. So uh, what if I increase it somewhat more, or what if we this time use this resizing? So maybe if I increase it to, let's say, what was the value they used, 442 or something. So they used 460, so I'm gonna use the same value for this time, 460. And for the augmentation transform, I'm going to use 224. I'm going to keep let's say 0.75 for the minimum scale, and let's see what kind of results it gives us back. So we have got the data loaders. Let me check the training batch images. The 6 image doesn't look good. Let's try to train the model. So for somehow this twos are classified almost correctly most of the time. So 50% of the images of twos are classified correctly, and almost 50%, and all the 50% are classified as sixes. 8.21 error rate. Oops, started increasing again. But somehow the training loss has been going down. Like it got almost 0.10. So what do we should be doing? I tried to use the different transformation, but it didn't improve our model that much. Let me check the confusion matrix this time as well. Oops, we are getting a perfect straight line. And we have only 18 thumb images, and most of the other images are almost 30. So they're almost twice the size of this thumb images, yet this thumb images are dominating our model. Let me check the batch size of validation set. So all of these images are being classified as 6, and I don't know why this should be happening. And if this keeps happening, I might have to either change the data set, or like find another data set, or create my own, or create edit this images only, because this is definitely not working. And I am not sure how this images will generalize to, images from webcam, like this. So yeah, and definitely we can't directly provide this image, which you can see in the webcam right now, directly to the model. We will have to uh, take out this portion, like detect a hand, and apply grayscaling or all that computer vision things, and then apply the model to that image. But before we can do that, we first have to get a working model, and it seems that I can't get it to work somehow. I have tried different transformation steps. if in the randomized resize crop, let me check what arguments we can provide. Let me try to Google something. Maybe someone has come across this kind of problem before. What if my data set contains most of the images of same size, but only one class of images are of different size? How to apply deep learning model to it? To resize images. Let me check this transformation again. Resizing to 128 by 128 and using the squishing resize method. I have to get the data loaders first. Let's check the images in the training set. Alright, so the images, they are squished, so they don't look good because all of these are scaled, but these images are very tiny because they are basically squished. What the hell happened? Wait, did my internet connection got disabled? Let me check my connection. Let me check the validation size. Even the notebook got disconnected. I hope that I didn't lose the connection to Google Drive. but we are getting kind of good results in there, and I'm not sure why this model didn't work, because we are getting almost good images. So let's try to train the model on those images. Should at least give us some adequate results. Let me save the notebook because my internet connection is fluctuating a bit. It might get disconnected anytime. The stream might be getting a bit unstable, I guess. Both YouTube and Twitch is showing me that it is unstable. I hope I at least get to see the results of this training example before my internet connection gets lost for good, because it is like fluctuating like hell. Anytime it might get disconnected. So I'm getting 0.55 rate, 0.65, 0.67. Nope, nothing really changed. It's still behaving exactly like before. It has started to overfit again. Meanwhile, the training loss has been going down, like it got almost up to 0.02. Let's just, for the convention, let's plot the confusion matrix for the heck of it. Oops. Huh. We are still getting a straight line and we are getting patches, and again we are getting almost good results for only 2, and almost all of the other classes are incorrectly classified. So this is definitely not a good model. By the way guys, my internet connection is bit laggy, so I guess I will keep the stream up to this point only, and I might try to tweak the model again in the next stream. And I've been tweaking this model for almost an hour now, and I didn't really find any good optimization technique which can improve our model. So I'm hopeful, but we will see. We will try some more techniques. We'll get it to work in the next stream. So guys, stay tuned for the next stream. We'll try to optimize this model again. So have a nice day or night or whatever it is for you.